Welcome back, everybody. We are looking at special lines today. This is associated with homework 13. So let's get ready. Let's get that notebook. Let's get that paper. Let's get ready to do this. Okay, fans. So today, listen, welcome. We're going to be talking about special lines. Now, when we mention special lines, like we've been talking about all types of graphs where the slope is negative, the slope is positive. Now we're going to look at a few situations where the slope is a bit different depending on how the line is graphed. And then we're going to look at a couple scenarios that it just have a particular special circumstance about that. So let's just jump right into it. So here we're going to be looking at, here we have a horizontal line here, friends, right? So we have this horizontal line and it's going straight across, and here's this point 4, 5 that sits on this line. Now, if I were to pick another point on this line, right, I'm going to pick right here. And just for argument's sakes, it's just another point in this line, but if I read my graph right, this point is 2, 5. Now, you may already know the slope for a horizontal line, but just in case you didn't know, right, you could calculate that. Remembering that the slope is the change in y over the change in x. So I'm going to use these 2 points here, right? The change in y. So since these are my 2 points, I'm going to go 5, 4 minus 5, 2. Hopefully you caught how I did that. Now, eventually I'm going to get this, and we know that anything divided by 0 is just going to be 0. So my slope of horizontal lines is always going to be 0. Now, if I wanted to write it in this form, if I wanted to write the equation of this line, right, here's my form of y equals mx plus b, my slope-intercept form. Well, I know my slope is 0, so here I would need to find my y-intercept. The y-intercept, if we remember, is the point where the line interacts with the y-axis. So this point here is 0, 5, which makes b 5. Remember, if this ordered pair is 0, 5, when x is 0, y is 5, that means b is 5. So my equation, since we already know my slope is 0, if I were to substitute, that would be y equals 0x plus 5, or y, move this out the way, or y equals 5. Anytime you see a number, sorry, y equaling a constant, right? The other way we write this, you see the form of it. The form for a horizontal line is just y equals c, where c is just any number, right? C could be 10, it could be -4, it could be -2/3, it could be 1/4, it could be 1,000. Anytime you see y equals a number, it is a horizontal line, and all horizontal lines have 0 slopes. Okay? Now let's talk about horizontal. Now what we're going to do is we're going to use the same point. We're going to use the same point to make to prove what we're talking about here. So the same point, 4, 5. Notice, right? So I'm at the same point. I'm going to use the same point of 4, 5. But I'm going to make it vertical. Now I want to talk vertical lines. Lines that are perfectly straight up and down. This isn't going to be perfect, so please forgive me. In the same vein, you may already know what the slope of this is. But let's say I pick another point on this line. I'm going to come down here. I picked 4, 5. I'm going to come down here and pick 4, 2. I mean, it doesn't matter. You can use any point that you want as long as it's on that line. And let's say I wanted you to determine the slope of this. Well, change in y. over change in x, the change in y, 5 minus 2 over 4 minus 4. You're going to get 3 over 0. Careful here, friends. 3 divided by 0 is not 0. You can't take something, right? I can't take this marker and divide it or chop it into nothing. I can't take something and divide it into nothing. So this is not 0. That is 0. This is, since we can't do it, we call it undefined. There's no defined slope for this whatsoever. And since there's no defined slope for this, there's no y-intercept, right? The y-intercept is when the line interacts with the y-axis. This line does not interact with the y-axis. So with vertical lines, there's no y-intercept. And since there's no y-intercept, the way we write this, if you notice that if I were to pick a different line on here, or sorry, a different point on here, like this point here, this point would be 4, 4. Notice the x values. If I pick any point on this line, the x value is going to be 4. So your equation is just x equals 4. Or remembering the form, y'all, remembering the form, right? X equals c. So if you see an equation where it says x equals a constant, right? C is constant. We should put that somewhere. C is constant. Make sure that is somewhere in your memory banks. X equals 10, x equals 74, x equals 2.78. Vertical line. And vertical lines have an undefined, I'm going to write this over so you can see it, undefined slope. Cannot define this. Two more things. Very good, very good, very good. Now let's take a second to talk parallel lines. Okay, looking at this graphic here, parallel lines. So in this sketch, these two lines will never touch. Parallel lines, they never meet, they would never intersect. That doesn't happen at all. They will go on forever in both directions and not touch. What do you notice? The red line, that equation, sorry for the closeness here, but this equation is y equals 2x plus 3, and this equation is y equals 2x plus 1. So my question is, what do you notice about the slopes? Remembering looking at our form here, y equals mx plus b, what do you notice about our slopes? Right, parallel lines have the same slope, which makes sense. If they're never going to touch, they need to be going slanted in the same direction. If they're slanted in different directions, they're going to interact with each other. They're going to intersect. So parallel lines have the same slope. And even though they contain different y-intercepts, that's fine. Now, obviously, if they had the same y-intercept, then it's the same line because they would just be on top of each other, right? So same slope. For the most part, different y-intercept. So if I asked you, if I gave you an example, said, hey, here's an equation of a line, for example, 4x minus 4. And I wanted you to write me any equation of a line that is parallel to this. It's parallel to this. Well, you know you're going to start with this form, y equals, and because they're parallel, they have to have the same slope, but different y-intercept. So your answer could be y equals 4x plus 1. There's a different one, or plus 10, or y equals 4x. As long as the slope is the same and the intercept, the y-intercept is different, you have given an example of a parallel line. Okay. Let's flip it over here. Now, let's talk perpendicular. Okay, Perpendicular lines. Our last special case here. Perpendicular. Now, when something is perpendicular, right, that means the lines meet at a very specific angle, at a 90-degree angle. The angles are 90 degrees. Okay, perpendicular lines. Now, here's an example of two lines that are perpendicular to each other. The red line is y equals negative 1/2 x plus 1. And this one here is y equals 2x plus 1. Now, we used the purple one from the last time, right? We used the purple one, the same purple one from here, to just accentuate the point that I'm trying to make here. And what do you notice? Look at these slopes. Now, we did that form again, so I'm going to put that form back just so we can have it in our brains as we're working here. What do you notice about the slopes? This slope is negative 1/2, and this slope is 2. So imagine if I could write that as, you might be seeing it, 1/2, 2, 1/2, 2. What if that was 2 over 1? Does that make it a bit clearer? How do you say that? Well, the slopes for perpendicular are what we refer to as negative. Now, I'm going to use the word opposite. I'm going to say negative. It's a negative reciprocal, but I'm going to put the word opposite here for you. The negative reciprocal. Right? So the inverse of positive 2 is negative. The reciprocal of 2 is 1/2. Now, you notice that the y-intercepts are the same. So what? Doesn't matter. Y-intercepts can be different. Y-intercepts can be the same. They still can be perpendicular lines. Y-intercepts, don't worry too much about it. So to this point, right, just to kind of get it in your head, a quick example, if I said, okay, here's an equation of a line, 3x plus 5, give me an example, any example of an equation of a line that is perpendicular to this. So if it's perpendicular, that means we know it needs to be negative. So instead of 3, it's going to be negative 3, and it needs to be a reciprocal. So that's 1/3. So we know that your answer has to be negative 1/3 x plus anything. It could be plus 1. Honestly, it could be plus 5. All right. It could be plus 0. It could be plus 10. Now, the reason why I use opposite, because check this out. Let me give you a different example. Let me say I'm asking for an equation of a line that is negative 2x minus 2. So that means, as you guessed it, since it's already negative, the answer needs to be positive, or the opposite. That's why I said opposite. And then reciprocal. So your answer should be positive 1/2 x plus anything, or minus anything. Let's do one more for the road. Final example. What would you say the answer is? Negative reciprocal. You got it. So it's just negative 3 over 2x minus or plus 2. Okay? Perpendicular lines, parallel lines, vertical lines, and horizontal lines. That's what we're going to cover today in special lines. Hopefully that did it for you. Let's take a look at homework 13. And as always, if you have any questions, please let me know. But other than that, thank you so much for hanging out. It was awesome.